All right, so I am going to go through Chapter 15's problems right now, and then later I'm going to do Chapter 7 and 8. I just want to do a quick run through first and double check to see what I'm doing before I go and do that. Okay, so if you have 250 mLs of a 1 to 800 volume per volume ratioed solution, and then it was diluted to 1,000 milliliters, what would be the ratio strength? So let's figure out 1 to 800 ratio is really hard to actually know off the top of your head what it is. Let's convert that 1 to 800 to its percentage. You would divide that by 100, and you get 1 over 8. Because it's a 1 to 8 ratio, once you change it to percentage, which is 12.5%. And you can find that out by just doing doop, like that. And you'll find, aha, see? So then we're going to take and figure out how many milliliters of the 250 milliliters are actual drug. Let me double check this just a second. Yep. Okay. And then you take the amount of milliliters of the active ingredient. 3125, and then it's going to be diluted up to 1,000 milliliters, which is 125, I think, percent. And then, so you want to figure out the ratio. So you have to take the percent, change it back to its real number, I believe. And then you divide both sides by that number. So 1 divided by 0.03125. 3,200. And that is how you get your answer. All right, if a pharmacist added 12 grams of azelaic acid to 50 grams of an ointment containing 15% of this acid, what would be the final concentration of the acid in the ointment? So I want to figure out how many grams of acid are already in the ointment. So we take the percent and multiply it by the total of the ointment that we are adding it to, and we find that that is 7.5 grams. And then, then you would add 12 plus 7.5, because that's how much we're going to add. And that's 19.5 grams. And then you have 19.5 grams of the acid divided by the 50 grams of the ointment, and then the 12 grams of the acid we're adding to make our total out of the bottom. So let's see, 19.5 divided by all right, 0.3145. All right, and then that is 31.45%. Okay. If 400 milliliters of a 20% solution were diluted to 2 liters, what would be the percentage strength? So 400 milliliters, we're going to find the amount of active, which is 80 milliliters, because 10% would be 40, and then double of that, because it's 20%, is 80. And then we're going to take the 80 and divide it by 2,000, because that is our 2 liters. And then that is 4%. I don't think it's about weight per volume. Oh well, it works out. All right, it comes in a Bactroban ointment comes in at 2% miprocin. How many grams of polyethylene glycol ointment base must be mixed with the contents of a 22 gram of the Bactroban ointment to prepare one having a concentration of 5 milligrams per gram? Okay, so let's figure out how much active ingredient we actually have. So let's take 22 grams times all right, so then that would be 440 milligrams. So then take 440 milligrams divided by 22 grams. That is 20 milligrams per gram. So that is 4 times as large as that. So that means that we can, to dilute it, we're going to need 1 part this and 3 parts of something else, which is the other ointment base. So we already have the 1 part, which is the 22 grams, and then we're going to need the other parts are going to have to be the same size, but we need 3 of them. So this is 66 grams of the ointment. Now if we, just to double check, because we need 4 parts, so we take 440 and divide it by, because we'd have to have the 66 to 88. And then that is 5 milligrams per gram. So this 66 gram is the ointment that we have to add. That's the polyethylene glycol. All right, how many milliliters of a 1 to 50 ratio weight per volume boric acid solution can be prepared from 500 milliliters of a 5% weight per volume boric acid solution? Okay, so we have to first change this ratio strength. So 1 to 50, you want to divide the 50 by 100, and that is a half, and that is divided by 1, so then that is 2%. So then we take the 500 mLs that we currently have, because we're going to be adding, and that is at 5%, and we want to know how much to get to 2%. So this will give us the total solution, not the amount of diluent. So be aware that you don't get caught. So multiply 500 ml times 5, and then divide it by 2, which, so very simple mathematics. Oh, how many milliliters? Okay, can be prepared. All right. So yeah, so 1250 ml. Yep. So that is how much can be prepared from that. But yeah, you do want to be careful because later on it'll ask you how much diluent do you add. And if we were adding diluent to that one, we already had the 500 mLs, so we would have to take the 500 mLs from the 1250 and we would end up with 750. So make sure that you know what they're asking for. Ruff's toxicodendron extract is 10 micrograms per milliliter. Sterile water for injection as needed to 100 ml. Make as directed. How many milliliters of a 100 milligram per milliliter concentrate of the toxic extract, essentially, should be used in preparing the prescription? Okay, so I am going to convert this to milligrams per milliliter, which is going to be 0.1 milligrams per milliliter. And then we're going to be using 100 milliliters of that. And that will find you how many milligrams it is. And this is the ratio of what we have in the concentrate. And we don't know how much we have to add for the concentrate. So this times that divided by that will essentially eliminate these two off this side. So your answer becomes 0.1 milliliter that you add to 100 mLs of sterile water. Or, well, you add that and then the rest is like 99.99 milliliters of sterile water. Sorry, let me circle this so that I know it's right answer. All right. A pharmacist receives 60 ml for an oral solution containing memantine, 150 milligrams per milliliter, She has on hand a 360 milliliter bottle of oral solution containing 10 milligrams per 5 milliliters and a diluent of sorbitol. How many milliliters of each should be used to fill this order? Okay. So the order calls for 60 mLs, and we want it at this concentration. And so we have that concentration, which is essentially 2 milligrams per milliliter, but I don't care because the ratios will work out later. And then divide by essentially 2 because that becomes 2. So 60 times 1.5 divided by 2, 45. So we need 45 milliliters of the memantine. And then, so that means that we have to take 60 minus 45 to find out the diluent, which is 15 milliliters. So then you have 15 milliliters of the sorbitol. Yes. And for those of you who don't know what sorbitol is just like a sugar syrup, if I remember correctly, because it's a sugar alcohol. So find that is in some stuff because anything sweet will cover up bitter taste of anything. And see, yeah, we did get that right. So let me go through that. All right, how many milliliters of 95% sulfuric acid having a specific gravity of 1.820 would be used in preparing 2 liters of 10% weight per volume acid? This one has a couple of steps. So 2,000 milliliters, and we want to have it containing 10% acid, is going to be 200 milliliters. But it's what we have is a weight per weight, not a weight per volume. So this is our volume. So we need the weight, technically. But it's like, it's not quite. Or this is milligrams or something. Yeah, I think that's milligrams. Sorry. And so milligrams divided by the specific gravity, which says that there's 1.2 grams per milliliter. So let me find out that there is that many milliliters. But this isn't our answer because this is if it was 100% acid, which it is not. So just take this and you divide it by 0.95 because that is our percentage. And you find that is 115.6737 milliliters. Really just 115 and a half-ish milliliters of acid that you have to add that's 95%. All right. How many milliliters of a suspension base must be mixed in with 250 milliliters of Paxil if 10 milligrams for 5 milligrams? All right, so to change the so we're in two different worlds. So we can go one way or the other. We can either go from the percentage and go into the actual weight per volume, or we can go from the weight per volume and go to the percentage. I am going to go the way of the weight per volume and go into percentage. So that we're working on a 1-to-1. So 10 milligrams for every 5 milliliters is the same as 200 milligrams for every 100 mLs. And you can tell this is a weight per volume, but it is not in the right units. It needs to be in grams per milliliter. So that would be 0.2 grams for every 100 mLs. So then that is our percent. So now we have our two different percents. So we have 250 mLs of the 0.02% weight per volume, and we're trying to go to the 1%. So we're just going to double the amount of fluid. So you would just add 250 mLs, because then you could essentially half the amount of concentration, which is what we're doing. So this, your total solution in the end would be 500 mLs, but the amount of diluent that you would have to add would have to be 1250 mLs, because you're just doubling it. Unfortunately, I don't really like, for me, this is very common sense, so I don't have like a mathematical way to explain it as well as I wish I could. But that is right. Okay, so a insect venom concentrate for immunotherapy contains 100 micrograms per milliliter. How many milliliters of water should be added to 1.2 milliliters of the venom concentrate to yield a 1 to 100,000 dilution? So there are different reasons for doing this, because a lot of people probably would be looking at this and going, I don't see the point in taking a whole bunch of venom. Well, so for those of you not knowing, insect venoms and different kinds of venoms are very useful in the pharmacy world. But back to the problem at hand. So we need to change this to its percentage, because I like percents. Well, and it would make more sense. So I'm going to change that. So then, that is the percent that we need to get to. So the amount that we have is 100 micrograms, and that would be 0.1 milligrams for 1 milliliter. Sorry. So let me back up. So that's what that is. And then, so if we multiply this by 100, we get 10 milligrams for every 100 milliliters. And then that is 0.01 grams for every 100 mLs, which is 0.01%. Now that, if we took 0.01 divided by 0.001, you would find that that's 10. So that is our ratio. So to get the current concentration to the concentration that we want, we need to add 9 parts. So 10 parts, one of those is really what we need, but one of those 10 parts is already made. It's 1.2 mLs. So multiply that by 10, our whole entire solution has to be 12 milliliters, but it's already taken up by that. So you take 12 minus 1.2 mLs, and you find that that is 10.8 milliliters of water that you have to add to come down that strength. So there is your answer. All right. If equal portions of tretinoin gel, 1% weight per weight, and 0.04% are combined, what would be the result percentage strength? So let's say hypothetically that we add 1 milliliter of this, of both. Okay, so we would have 1 milligram, let's say hypothetically, and 0.04 milligrams. So then you would have per milliliter, so per 1 ml. So you would have 0.14 milligrams per 2 ml, because you had to add these two as well. Well, so then that would be 0.07 milligram per 1 ml, which is, it's not really accurate, but it'll get you the answer. So, so your resulting strength is 0.07%. I'm just lazy. I'm not going to go into more detail. All right. So, how many milliliters of a 0.02% solution of a skin test antigen must be used to prepare 4 mLs of a solution containing 0.04 milligram per milliliter? Okay, so we first have to change one of the two to the same units. I'm a fan of changing the 0.4 milligrams per milliliter to 1%. So, but you can go either way. So then you want to take that, multiply it by 100, find that that's 100 mLs. Then you find that 0.004 grams, 100 ml, and that is 0.004%. Okay, so then we're going to be doing 4 milliliters of the solution at 0.004%, and then we're going to have the equivalent strength amount. So we have to know how many mLs on that side. All right, so we find that ml. I believe that's right. Yep. All right, a drug is commercially available in capsules, each containing 12.5 of the drug and 37.5 diluent. It's an aliquot. Okay. How many milligrams of an additional diluent must be added to the contents of one capsule to make a dilution containing half of a milligram of drug in each 100 milligrams of powder? Okay. So, how many half a milligrams do we have? So how many parts do we have? We're going to take the total amount of milligrams and divide it by the amount that we're going to need. And that should equal 25. No, all right, so yes, that does equal 25. So 25 parts. And so then that needs to be per every 100 ml. So that is 25 times 100 milligrams. And that's 2,500 milligrams. But then we already have, so we have currently 12.5, 12.5 plus 37.5, that is 50 milligrams. So that's what we currently have. So we don't need to add that 50 milligrams. We just need to add the diluent. So we need to add, we need to take away that 50 milligrams. So then that diluent that we have to add is 2450 milligrams to get to that strength. Yep. All right, in what proportion should we add 1% and 5% hydrocortisone ointments to make a 2.5%? So I'm going to do this in one part to show you guys how to do it, and then another part to show you how to double check it if you ever feel like you're unsure of your answer. So you have 5%, you have 1%, then you have your 2.5%. So you take 2.5 minus 1, that equals 1.5. And then you have 5 minus 2.5, and that equals 2.5. Well, we can't have these 5s, so we have to divide them by 0.5, and that equals 5. And this one divided by 0.5 equals 3. So then that means we have 3 parts of 5% ointment, and then 5 parts of the 1%. And that seems to make sense because you would need more of the 1% than you would need of the 5%. Now, if it was, let's say, 0% to get 2.5%, which is essentially a diluent, you would find that you would need 2.5. It would need to be equal. So this way, it's a little bit unequal. So let me show you how to double check this. So let's say hypothetically that we decided to make this ointment. So sure. So we're going to do the 5 parts of the 1%, and then 3 parts of the the 5%. Yes. Okay. So then you would have 300 milliliters. Now you need to add these two together. So you find that it's 20 grams, because it's 5 plus 15, over 800 mLs. So 20 divided by 800, and you find that that is 0.25, which is 2.5%. So it does work. So if you ever get stumped and you think that you're if you think you're not adding the right amounts, this is a way to double check it. All right, we're down to the last question. Okay, this one's super easy, but it can be a little bit tricky. So they want to know how many milliliters of sterile water should be added to a vial containing 5 micrograms per milliliter of drug to prepare a solution containing 1.5 milligrams per milliliter of the drug. So we don't have to convert anything, which is nice. And we're going to assume that we're dispensing 1 milliliter because they don't give you a number. So you just always assume. And we just don't know how many mLs of equivalent would that be. So 5 divided by 1.5. All right, that would be 3.33 ml. That means repeating on to infinity. Now the problem with this is that is the total amount of solution. You have one solution, 1 milliliter already. So you have to take away that 1 ml to know how much sterile water you have to add to get this solution to that. So it's 2.33 ml of sterile water that you have to add. If I know how to write today. So that's how much you have to add. So tiny bit tricky, but not too tricky. And that's it. And I will come back and do chapter 7 and 8 in a second.